We're going to do the limit of tangent 2x over x as x approaches 0. The first thing we're going to have to do is plug the 0 for the, every time you see x. So it could be 2x over 0, which equals 0. We can't have that. So we're going to have to change the function to limit as sine is 2x over cosine 2x x as x approaches 0. So, and then we're going to use this function right here, limit of sine theta over theta as theta equals 0, which equals 1. So right now we got an x. So to have this in the denominator, we gotta have 2. So we're gonna have times this by 2, and whatever else we don't need, we move over to the side, which is gonna be wow, I'm tripping. Right now we have 2x over 2x, so we good. Which this would, all this would equal 1 times 2 over cosine 2x. Then we would bring this down, limit x approaches 0. Then plug in 0 for to x. Would be 1 times 2 over cosine 2 times 0, which would be 2 over 1, which equals 2. Next problem is the limit of 2x over 8, x over plus 8. As x approaches negative 8 to the right. First thing we're going to do is plug in the negative 8 to x, which is negative 8. Which is negative 16 over 0, which equals plus a negative affinity. Alright, so right now we're going to have to use this, go to the line, negative 8. And we're going to go to half a number to the right, since it's the plus right here, which is negative 7.5. So we're gonna plug in negative 7.5 to this function right here, which is which is going to equals negative 15 over 0.5, which is negative 30. So the affinity right here is going to be negative affinity. And it says find the Find the vertical asymptotes, which is x equals -8.
I don't want to stop. Okay, I'm going to find the horizontal asymptote of the function, the limit of 4 minus 3x squared over the square root of x to the 6 minus 9. The first thing I'm going to do is substitute the infinity in the highest exponent of the numerator and the highest exponent of the denominator. So I'm going to have this. I'm going to keep, I can drop my limit because I'm doing substitution. That look like infinity? No? Okay, it doesn't matter. Like that. And it's going to give me infinity. And this leaves the answer as indeterminate. So now I have to divide all of these terms by the highest exponent, which is x to the 6. And for the numerator and denominator, for the two terms in the numerator, I will change the exponent to be x3 because that's the answer when you find the square root of x to the 6. And then we're going to do the same thing for the numerator. We're going to remember to keep our radical. Okay, and now our next step is to cancel out all that we do not, cancel out like terms, I should say. So now we will still keep the limit. And now here I will just start my substitution again. And this, now I will simplify it. I'm going to have 0, 0, 1 minus 0. Everything is still underneath this radical. And when I evaluate all, I'm still going to come out with 0. Therefore, the equation of the horizontal asymptote is y is equal to 0. And for this graph, I will have to find the limit of f of x as x approaches -4. And from the line, -4 is right here. As you can see, where the line approaches -4, but it never reaches -4. Therefore, the limit is infinity. Then I have to find the limit of f of x as x approaches -4 from the right. The plus sign is the right indicator. So coming from the right, it approaches, but it never touches, and it leaves it as positive infinity. And we're going to put this right sign. And then, lastly, I will find the limit of f of x as x approaches -4 from the left. As you can see, I will do it with my finger. It approaches it, but it never touches it. And that is infinity from the left. Okay, so I will use this graph to find the limit of f of x as x approaches -4. So I'm going to do the finger test. And as it approaches -4, the lines they get closer and closer, but they never touch. Therefore, the limit do not exist. For the limit of f of x as x approaches -4 from the right, I'm going to take it, and my finger is going to get closer and closer to -4, but it never touched. Therefore, the answer is positive infinity. I'm going to find the limit of f of x as x approaches -4 from the left finger, and as it approaches, but it never touches. Therefore, the answer is negative infinity. Now, I'm going to find the limit of f of x as x approaches infinity, and the answer is -1 because of the finger test. So it approaches, and it's there. And the limit of f of x as x approaches negative infinity, the answer is 2. It approaches and it touches. 2.